Hello students, welcome to physics class. Today we discuss some indirect method of length measurement. We are very familiar with the direct method of length measurement. By using a meter scale, we can measure a length within a range of 10 raised to minus 3 meter to 10 raised to 2 meter. By using a meter scale, we can measure from 1 millimeter to 100 meter, 10 raised to 2 meter. By using a screw gauge or by using a vernier caliper, we can measure up to 10 raised to minus 4 meter by using a vernier caliper. By using a screw gauge, we can measure up to 10 raised to minus 5 meter. If our length is too small or too large, we have to use some indirect method of length measurement. Let us see what are the very common indirect method of length measurement. First, see a triangulation method. The triangulation method or trigonometric method. Here, we are supposed to measure the height of a tall tower. In this diagram, AB is a tall tower or tree having a height h. We want to measure this height h by some indirect method. We cannot directly measure this height. So in order to measure that height, suppose we are standing at a point C. We are standing at a point C which is at a distance x from the height h. From AB, we are standing x distance at a point C. And we are just observing what is the angle made by the point A at the point C. We are measuring that angle. Let that angle is theta. It is known as the angle of elevations. After getting the angle theta, by using the trigonometric relations, you can write as tan theta. Tan theta is equal to, actually it is opposite side by adjacent side. Tan theta, we are writing tan theta is equal to AB by CB. AB by CB. And AB is equal to h, the height actually you want to measure, and x is the distance of our observation point from AB. So that is x. So the h is equal to x tan theta. If the distance x is measurable, if you know the angle theta, we can find the height of this tall tower or tree. That's h is equal to x into tan theta. This method is known as the triangulation method or trigonometric method for the measurement of height. Now, another method is parallax method. Usually this method is used to find the height or the distance to a heavenly body or distance to a star. Let us see what is the concept of this parallax. In order to explain this concept of parallax, suppose we are holding a pen or pencil just in front of you like this, and we are observing a point under a background, for example under the background of a wall. First, we are closing our left eye and observe that point through the tip of this pen. After that, you change your eye and close your right eye and observe that point. And you feel that the alignment of this pen and this point is changed. And this concept is known as the parallax. And parallax is defined like this way. This is the concept of parallax. The parallax is the apparent shift in the position of an object with respect to another when we shift our eye sideways. The parallax is the apparent shift in the position of an object with respect to another when we shift our eye sideways is known as parallax. To measure the distance to any heavenly body by parallax method, let us see what are the procedure. Suppose in the diagram, S is a heavenly body. We want to measure this distance to the S. So to measure that distance from the earth surface, suppose A and B are the two observation point. We are observing this point S or this heavenly body S from the two observation point A and B, and measuring what is the angle made by this heavenly body with this two observation point A and B. This direction of this observation point make an angle theta with that heavenly body, and usually that angle is known as parallactic angle. It is the angle made by that, it is the angle made by heavenly body with the direction of observatories. Let it be theta. As this angle is too small, as the distance to this heavenly body is very large, usually this angle will be very small. So by small angle approximation, we know that the angle is equal to arc by radius. As this angle is too small, we can consider this AB as an arc. Let's mark this distance between the two observation point as B, and distance to this heavenly body is capital T. So we are writing as the angle theta is equal to arc by radius. Angle is equal to, you know the equation, angle is equal to arc by radius. Angle is equal to arc by radius. Here the arc is equal to AB or is equal to B, and radius is equal to AS or BS, that's equal to D. So we are writing theta is equal to B by D. Theta is equal to B by D, or D is equal to B by theta. D is equal to B by theta. That is the distance to the heavenly body by parallax method. Once we are getting this distance to that heavenly body, we can also measure the diameter of that body. Let us see how can you measure the diameter of any heavenly body by using this parallax method. First, we are measuring the distance to that body by parallax method. After that, how to measure the diameter of that body. This is our heavenly body, and AB is diameter. We are marking the diameter as D. D is the diameter of that heavenly body. And in order to measure this diameter AB, we are observing from the surface of the earth. This is earth. We are observing this body from one observation point on the earth. Let this observation point is O. We are observing from this point the two diametrically opposite point on that heavenly body. Let A and B are the two diametrically opposite point, and AB represent the diameter. So we are measuring this angle theta made by these 2 points with the observation point on the earth. And usually that angle is known as the angular diameter. That angle is usually known as angular diameter. As the distance is too large, this angular diameter will be very small. And again, we are using the concept of small angle approximation. We can write the angle theta is equal to arc by radius. Angle theta, arc is equal to AB, AB by the radius. Radius can be written as either OA or OB. OA and OB is approximately equal to the S, the distance that we measured by parallax method. So substitute that theta is equal to AB is equal to D, and OB and OA is approximately equal to S. So we can measure the diameter as D is equal to S into theta. D is equal to S into theta. So this is the parallax method to measure a very large distance. Example, distance to the sun and distance to the planet or distance to any heavenly body can be measured by using this parallax method. Now let us see how can you measure a very small length by using some indirect method. We know that we can measure a length 10 raised to minus 3 meter by using a meter scale directly. If you are using a vernier caliper, we can measure up to 10 raised to minus 4 meter. And if you are using a screw gauge, we can measure up to 10 raised to minus 5 meter. And we have optical microscope which having a resolution up to 10 raised to minus 6 meter, and electron microscope having a resolution in the order of 10 raised to minus 9 meter for the direct method of length measurement. But how can you see or how can you measure a very small length indirectly? Let us see one method. Measure the size of oleic acid. We know that oleic acid is a soapy solution. We are forming a solution of oleic acid with alcohol like this. First, we are taking 1 centimeter cube of oleic acid and dissolve into alcohol to form 20 centimeter cube solution. We are taking 1 centimeter cube of oleic acid and dissolve into alcohol and form total 20 centimeter cube solution. From that solution, again we are taking 1 centimeter cube solution and again we are dissolved into alcohol and to form 20 centimeter cube of solution. Now what happened is, we getting a solution having concentration of oleic acid as 1 by 400 centimeter cube in 1 centimeter cube of alcohol. See the procedures once more. We are taking 1 centimeter cube of oleic acid and dissolve in alcohol to form 20 centimeter cube solution. From that solution, we are taking 1 centimeter cube, again dissolve into alcohol to form 20 centimeter cube solution. Now the concentration of oleic acid is 1 by 400 centimeter cube in 1 centimeter cube of alcohol. After that, we are taking few drops of such a solution and pour into water which is taken in a trough. Immediately after pouring, this solution will spread to the water surface by forming a very thin layer. That layer is actually a monomolecular layer of oleic acid. It means it is in the order of the size of the molecules. The thickness of that layer is approximately the size of this oleic acid. So once this layer is formed, the oleic acid layer is formed in water, we are measuring the area of the layer by using some graph paper, or we are measuring the area of that layer. Suppose A is the area of the layer that we measured. A is the area of the layer of oleic acid. And say that T is the thickness of that layer which we want to measure. The thickness is approximately will be the size of the oleic acid molecules. So before pouring, suppose we measured the volume of each drop of oleic acid solution is V. V is the volume of each drop. And if you pour n drops of solution into water, the total volume is n into V. The total volume of the drops which is poured into the water is n into V centimeter cube. But you know that in 1 centimeter cube of such solution, we have only 1 by 400 centimeter cube of oleic acid. So the amount of oleic acid is equal to volume, total volume, NV by 400 centimeter cube, because in 1 centimeter cube of solution, we have only 1 by 400 centimeter cube of oleic acid. So this is the volume of oleic acid in that layer. Now the thickness of the oil film or oleic acid film is equal to volume divided by area. Volume divided by area. Volume of the film divided by area of the film. What is the volume? Volume is equal to NV by 400. This is the volume NV by 400 divided by area. Let us say A is the area which we measured by using a graph paper. So this is actually the thickness of the layer, which is approximately the thickness of the oleic acid. As it is a monomolecular solution, and a monomolecular layer is formed though. So the thickness of this layer is approximately in the order of 10 raised to minus 9 meter, 10 raised to minus 9 meter, which is approximately the size of oleic acid. So this is the one of the rough method of measurement of the size of oleic acid, which is too small, which is in the order of 10 raised to minus 9 meter. So these are the some of the indirect method of measurement of length. Thank you.